Okay, so in machine learning under supervised learning domain, when we are performing classification, then we will have the training data which we will feed to the algorithm, and that training data will include the desired solution, which we can also call as labels. And those training data, those labels present in the training data, will basically help the algorithm to learn the pattern of the training examples during training. And once we have those training data with labels, and we have our algorithm being trained on the training examples, then we can expect that our algorithm will be trained enough or capable enough to perform on unseen data as well. So we will be talking about the unseen or test data later on. So now the first thing which you need to keep in mind is that when we perform classification under supervised learning domain, then we have our desired solutions along with the training data, and those desired solutions are also known as the labels of the training data. And here, if I explicitly explain with an example, then I can say that if I have some images of cats and I also have the cat label associated with each image, then I can say that my data is labeled data and my problem will fall under supervised learning domain. Another example is the classification of spam, right? For example, if I have emails and I have want to have a spam filter which will be basically capable of classifying my normal emails and my spam emails, then if I have already labels of the spam emails, then this will also come under the supervised learning task, right? So my training data will consist of emails that are already labeled as spam or normal, and my algorithm will learn about the normal email or the spam email based on that labels. So this is the basic definition of classification in the supervised learning domain. So here is the explanation of the example which I have just explained about my spam filter, right? So in my spam filter, I will have a set of emails, right? So you can see here in this diagram that I have different emails, and each email has an associated label with it, right? So here you can see that for this email or this instance of my training example, I have a label associated with it, and that associated label is telling me that it is a legitimate email, right? So it's not a spam. On the other hand, if we look at this instance, here we can see that this email is basically labeled as a spam email, right? So we have a label associated with each email, and that label can be spam or a normal category, right? So all these instances or all these emails will combinedly make a training data set, and this training set is basically used in order to train the algorithm, right? So once my algorithm has been trained on this training data set, then it will know that which email is a spam email and which email is a legitimate email. And then when I will provide it a new instance or a new sample or a new email which is not seen by my algorithm, and then based on this training, my algorithm will be able to classify this new instance or new email whether as a spam or a ham. So in this way, we will be doing the training of our algorithm under supervised learning domain, in which we will first be training our algorithm on a training data set, and we will provide different instances to the algorithm. We will also provide the labels of those instances, and my algorithm will be able to learn the differences between the two categories. And then I will give it an unknown instance or a new data sample, and based on this training, my algorithm will tell me or classify the unknown instance, right? So in the spam filter example, we have trained an algorithm with many example emails called training data, right? So this is my training data which have many different examples. Each email in the training data contains the label if it is spam or ham. Ham basically means not spam, right? So this label data or this label will tell my algorithm that either this instance is a spam instance or it's a ham instance. Models then learn to classify new emails if they are spam or ham, right? So once we have an algorithm trained on this training data set, then we can say that my model or algorithm, so sometimes I will use these two terminologies for the same thing, right? So now if I say my model or if I say my algorithm, then for the time being just keep in mind that this is the same thing. So then I can say that my model have learned about the spam or ham emails, and then when I provide it a new instance, then it can classify it as ham or a spam. So this was the discussion related to classification, and we have seen that what is the basic procedure if I want to train my algorithm for classification task under supervised learning domain. Now we know that the second category which falls under supervised learning domain is the regression problem, right? So sometimes we have classification problem and sometimes we have the regression problem. And in regression problem, as I have explained earlier, that we are basically trying to predict the value of an unknown variable, right? So for example, I want to predict the price of a car, right? So on the basis of some features, or on the basis of some known entities, or on the basis of some independent variables, we are basically trying to predict the value of an unknown variable, right? So you can also see in this graph here that I have basically some features. So this is my feature one here on the x-axis, and I have different values associated with them at the y-axis, right? So if I want to determine the value of an unknown instance, for example here I have an unknown instance or a new instance. So if I want to determine the value of this instance, then I can look into this regression graph, and with the help of this regression graph I can find the value of this new instance, right? So this was basically a very generalized explanation of a regression problem. So how it is different from the classification is that in regression we are trying to predict the price of a car, right? And we are predicting the price of that car with a given data set of features, right? So we have a set of features which is already given to us, and this set of features is also known as predictors, right? And those predictors can be mileage or age or brand. So depending upon the problem or application, my predictors will vary, right? So if I am developing some weather application, so maybe in that case my predictors will be some temperature and this kind of variables. So these predictors, which are basically a set of features which we have already known, and on the basis of these predictors or features we are basically predicting the value of an unknown entity under regression problem. So what we are doing here is we are training our model, and in during the training we have to give many examples, right? So it is very similar to the classification task. So we have numerous examples which we are basically providing to our classifier. Similar to that behavior in regression as well, we have many examples and we are providing it to our model, and those examples basically consist of the predictors. And what are those predictors? Those are basically the set of features which can vary depending upon the problems. And since we are again under supervised learning domain, so we also have our labels associated with them.